Okay, hello everyone. I hope you're fine. So this is Shahriar Mustaqimitu. So this is one of the expert talks for ML machine learning summer school for Bangladesh. So today we have a special guest with us. She's a Google developer expert, and who I believe, without any further ado, we'll just invite her to the stream, and obviously we'll learn about her, and obviously we'll today learn about AI agents, which is very much interesting. And today you might see about AI agents and so on, right, in the LinkedIn and so many and so forth, right? So okay, let's get started. Hello, hey Ken, can you hear me?
Yes, I can hear you.
Yeah, thank you so much for accepting our invitation for the session. So yeah, would you please introduce yourself and then can you start our session?
Okay, nice to see you, everyone. Thank you very much for joining my session. I am Ening Kai. I am a GDE Google Developer expert in AI, and currently I am a lecturer at the Department of Computer Engineering, KMUTT, Thailand. Actually, this is my second time contributing to the Bangladesh developer community. Back then in 2024, I also contributed a talk to Google Developer Group Dhaka. So I'm really honored to be here, and thank you, Mitu, for your invitation.
Yeah, thank you so much. So I believe we can get started with the session then.
Okay, let me share my screen.
Yeah.
Can you see my screen?
Yes, perfect.
Okay, good. So today we will learn what is an AI agent, and we will learn how to build a prototype LLM agent using Hugging Face and Vadas AI, which is a Google AI cloud platform. So today I'm going to cover the introduction of AI agent and the frameworks you can use to develop the AI agent models and the prototype using Hugging Face More agents and Vadas AI agent builder. And I will wrap up the presentation with giving some other results you can use in order to build the AI agents. So let's start from the history. So 20 years ago, when we talk about AI, it's basically a decision tree. You have to pick the features on your own. For example, if you want to build an AI model that can predict the heart attack or something like that, basically we rely on the decision tree model. And the decision tree model, those are still very useful nowadays. If you want to solve like a simple problem, linear problem, you can still rely on decision tree. And then also, in order to find the shorter path, we rely on the algorithms such as Dijkstra, Easter, and something like that. And then we move on to the machine learning era less 10 years ago. And then with the rise of neural networks, we no longer need to predefine the features by our own hands. We can rely on the neural networks, for example, convolutional neural network for image, and then recurrent neural network transformer model for like the text presentation in order to extract the feature from the given image, given corpus. And when we talk about LLM, we must know the word embedding, also known as the word to vet algorithm. That's an introduced in 2030, I believe, by the Google AI research team. So word embedding, also known as the word to vet, is a word representation technique like the vector representation of words. You can use this as an input to the large language model. So this is basically the intuition behind what to vet is you can predict the meaning of the words based on the surrounding words. For example, if you don't know the meaning of the target words, but if you know the meaning of the surrounding words, you can predict the meaning of the target words. That is the intuition behind what to vet. So the words which have the similar characteristic, for example, a laptop and computer, they will have similar representation, right? So this is the intuition behind what to vet that's emerged in 2013. And right now, we are in the era of LLM, large language model, and a vision language model, which can handle both image and then text. So those are based on the what embedding, what algorithm, what representation. So the LLM is like LLM are trained to predict the next token based on the previous token. So this is like a text generation model. And then after that, you can fine tune, you can train those LLM in order to perform specific tasks such as question answering, which is like we can talk to GPT, Gemini in that way. Those are specialized trained for the question and answering text using the LLM model. So So the start of the language model is actually not the transformer model. It starts from the engram model by dividing the words into the different tokens and then predict the next token based on the previous one. That is like we can easily see in our mobile phone keyboard. For example, it suggests what gonna be the next word based on our previous history, right? So this is we got task completion. And then another use case of the language model is the conversational chat, like a chatbot. And then we can also as LLM model, AI model in order to do specific tasks like question and answering. This is like chatbot, Gemini, ChatGPT. Those are question answering chatbot. And then the more advanced is the vision language model. So vision language model like Quan, those can handle both image and text data. So you can give the prompt to generate an image. So based on your prompt, it will generate an image, and also based on your image, it can also generate the caption that align to that image. That is the vision language model. So nowadays we are talking about the AI agents. So what is AI agents? AI agent is they can not only generate the output for us, they can also do the test for us. That is the AI agents. We don't need to do the manual test anymore. With the AI agents, you can rely on end-to-end pipeline or your text. So the official definition of the agent is it performs its goal by observing the world and act upon it. So yeah, when we were children, we learned how to walk, right? So yeah, we learned from our parents, and then we learn upon the environment, right? If we like fell down, we get up and something like that. So this is how we learned to walk. So AI agent is also that's the same. It observe the real world, it observe the words, and then perform the text based on that word. That is the official definition of AI agent. So imagine that like ordering a pizza. You want a pizza, but you don't need to know the details how to cook the pizza. You know that you want a pizza with chicken, pepperoni, and something like that. You just write down your instructions, and then the pizza restaurant will prepare the pizza for you. So we don't need to know the details. We just need to give the instruction. We want a pizza. So in order to make a pizza at the back end in the kitchen, the chef need the tools, right? Knife, cutter, utensil, and something like that. So that also applies to the LLM agents. LLM agents need the tools in order to deliver the task for you, like doing the pizza. So you don't need to know which tools gonna use in order to make a pizza. You just give the instruction. But in the kitchen, the chefs are preparing the pizza for you using the appropriate tools. So the same analogy applying to the LLM agents. So LLM agents has variety of tools, API functions in order to perform the task for you. And then based on the tools output, and they analyze and then give you the output. So what you give is just a prompt, but the LLM, they are assessing the different tools they have and give you the output. So as an AI engineer, you have to work together with models and the available tools in order to build the AI agent. So what is not an AI agent? If they give you just the output, that is not an AI agent. So they just give the prompt and get the output. This is not, we call an AI agent. This is just a prompting. And you ask the LLM in order to like provide the information, like for example, how to make pizza or something like that. So this is just the zero-shot prompting. This is not an AI agent. But if you ask the AI agent, okay, find the cheapest pizza in Dhaka or something like that and make the order. So if you are AI agent, find the cheapest pizza in Dhaka and then order for you, and if you get the pizza, that is the AI agent. So AI agents not only give you the output, but also perform the test for you. So this is like how we usually do the assignment in our university, right? We copy the questions, upload to the Gemini, and copy the answer and save in the DOS file and send it to the learning management system. And this is not the AI agent state, because you have to do manually, like copy the dot file, send an email or something like that. But if you can automate all of this, that this became an AI agent. And very soon, I will show you how to do this using the Hugging Face Small agent. So let's consider the submitting assignment. So you can imagine like what are the tasks in order to do the assignment as a human. So you have to answer the questions and you have to save it, the file, and upload to the system, right? So the same for the AI agent. So in order to perform these tasks as an AI agent, first is they have to access your notebook, right? Your textbook, your notes. In order to do the homework for you, you should give access your textbook, notes, and something like that, so that they can extract the correct answer from your textbook, not from hallucination. That is, it can be done by retrieval augmented generation (RAG), which is a technique that prevents LLM from hallucination. That's based on the traditional information retrieval. And also, they have to verify the answer. The agent have to verify the answer. And if they got the answer, another task is they have to create the document. And then after that, they have to send email to your professor, upload to the system, and something like that. So when we talk about AI agents is composed of four key components. The first component is the foundation model. So you have to decide which model you are going to use. Are you going to rely on the GPT, or are you going to rely on the Qwen, or are you going to rely on the Gemini or something like that? And then the next step is the tools. You have to identify which tools you are going to use for which text. For example, in order to save docs to PDF, which API you're going to use. In order to, for example, get the latest information about the stock data, exchange, currency exchange, or something like that, which API you're going to use. In order to make the hotel booking system, which API you're going to use. So you have to identify the tools in order to perform the task for the human. And then orchestration. Orchestration is that maintain the memory, that save the data from your process data. And then runtime is it executes the system when user give the prompt to your AI agent. So let's see this example. So the system prompt is, you are a meteorologist, use Python and web search to predict tomorrow temperature from open source data and answer some question. So in here, the task is predict tomorrow temperature. Okay, so in order to predict the temperature, you have to get access to the open source data. So your LLM has to call the tools API in order to get the data, right? You have to search in the web browser using the web browsing tools, or you have to use on the weather API in order to get the latest data. And then you have to verify the output. If the data you get is not correct, you have to update the memory again with the reliable source. Okay, so you may need to call at least 2 to 3 tools in order to identify the output. For example, you can rely on the weather API, and also you can rely on the web search in order to get the weather for today. And then if both of your tools give you the same similar answer, we can say that, oh, this answer could be true. If you like not satisfied with the 2 resource, 2 API calls, maybe you can increase 3, 4. But you may also want to consider the runtime, computational resource, and something like that. But if you find that among 4 API tools, those give you the different information about the weather, you may think that, oh, something might be wrong. Or if among 4 of them, only one is not correct, maybe you can consider that tool is not reliable anymore or something like that. So not only calling the tools, maybe you also need to identify which tool is more reliable for your agent in order to perform the tasks. So tools evaluation, tools calling is also very important in building LLM agent. So this is the flowchart I adapted from the ChipQM. I recommend AI engineering book or ChipQM. This book is a very good book in order to learn about the foundation models and AI engineering. So the first one is you give the system to the query prompt, and then your AI agent must plan how to execute the text. For example, if you give the prompt in order to find the cheapest pizza in Dhaka, so how your LLM will do this steps? You say the LLM agent, find the cheapest pizza in Dhaka and order and deliver to my place or something like that. So, well, LLM agent have to find all the pizza restaurant first and then sort by the price or something like that, or they have to find the cheaper restaurant first. They have 2 ways, right? Finding the cheaper restaurant first and finding the pizza restaurant first. What could be the most efficient way? Maybe like filtering by the pizza type might be more efficient. Maybe because in 100 restaurants in Dhaka, maybe only we have 5 restaurants are pizza restaurants. So in that case, filtering by restaurant type might be more efficient, right? Because from that 5 restaurants, we can easily select the most cheapest one or something like that. But we know how to execute this query as the human, but for LLM, they might not know, right? So we also need to evaluate how LLM plan your requested query as an LLM engineer. That's also important thing. You have to evaluate the planning in the development state, not only the output. That's why now you can see in the Gemini GPT how your agent is thinking in order to give you the answer. Like if you click the thought process, you can read the thought process of your LLM agent, and by just reading this, even as an end user, you can identify whether your LLM giving you the correct answer or not. And then after you evaluate the output, and then if that's certified, you can choose the tools, and then you can give the output to the end users. I also would like to introduce different types of agents. The first agent is React, that is like reason and add. And then another one is Code Agent. Code Agent is it pre-plans all the steps, not like React Agent. React Agent is it's step by step. React Agent plans step by step or your system prompt, your query, but Code Agent is pre-plan all the steps and give you the output. nowadays, like we are using code agents a lot, right? We just give the prompt and then LLM write the output for us in the programming language we desire, Python, Java, C, or something like that. And then single agents and multi-agent. And single agent is like we rely on only a single agent for the whole system. And the multi-agent is we rely on more than one agent for the different tasks. For example, like when we order let's think about the pizza ordering, we can rely on the single agent from finding the cheaper restaurant, finding the cheaper pizza to order. But you can also have a multi-agent, one agent for finding the cheapest pizza and one agent for taking care of the order and something like that. You can specialize each agent with its own capability. So here is the example of the React agent and code agent, right? The code agent is quite straightforward. Let's say the prompt is to find and book the cheaper flight from Bangkok to Dojo. So the code agent is, it will find the Bangkok to Dojo flight for January 25th from the flight API, and then it will find the cheapest flight and do the booking. But the React agent is step-by-step thing. It's reason first. Okay, you can see those reasoning steps in the GPT-5, GPT-4, in latest Gemini, and something like that. The reason is, okay, first I will find the available flight from Bangkok to Dojo, and the second step is identify the cheaper flight or something like that. You can also identify the step your LLM agent is performing to achieve your goal. Okay, so in this presentation, I will show you two ways in order to do the AI agent prototype. The first one is the small agent using the Hugging Face. For that, you need some like coding skill in order to perform in order to develop the AI agent. Another one is the agent builder from Google. You need very minimum coding skill in order to do the AI agent on the agent builder. But one thing to know is Flutter AI is quite expensive, at least for me. So yeah, careful about the cost and then evaluate costs and drawbacks of each tools you are use. Okay, so in order to build the Hugging Face small agent, the first thing is you must have the Hugging Face account and you must have the access token. In order to pick the agent, you can easily get it in the Hugging Face your account. And then building AI agent with Hugging Face is quite straightforward. You can use the small agent libraries from the Hugging Face, and then you can call the inference client model. That's the default is Qwen 2.5 vision language model. And in the tools parameters, you can identify the tools you want to call. There are like publicly available tools, and also you can identify your own tools if you want and pass it as a parameter. That is how you can use Hugging Face in order to develop the agents. Okay, let me show hands-on. Okay. Okay. So here is the Hugging Face access token. You can create the access token in your Hugging Face profile, and you can also set the permission according to its need. Usually we give the rewrite assets. If you want to create token, here you can just need to create a token, give the token name, and give the necessary access, and then create token. After that, you will get access the token, and you have to copy it, and also you have to remember your access token name in order to use in your Python code notebook or any Jupyter notebook. Okay, so if you are developing using Google Colab, you can put your key access here. For example, here, this is my Hugging Face token. That's you can copy it earlier from one after you create that from Hugging Face. And let's see the notebook. So the first step is you have to install the necessary libraries. And I will clone the GitHub repository prepared by another AIGDE Tiwari. And we get them. And we will import the Hugging Face token. And you have to use the Hugging Face login command in order to give your notebook to your Hugging Face access token. And after that, this is installing the data code search API that will be used as the external tools in your agent. And the first one is simple agent using OpenMoret. You may see that there is nothing in the tools parameter, right? That means we don't call any tools. We just rely on the LLM like output in order to see the result. So the question is like, when was the last time in year 2020 work at? So this is the what you will see is the output without using any external tools. So this is the answer from the Quant 2.5 More. Another one is, in this time, we give the data growth search API as the tools. So your agent assess the existing knowledge from your LLM Quant model, plus they can also have access to the data growth search. So they can also search the information in the data growth search engine as well. So this is the answer from the DataGo search engine. And this is, oh, sorry. Oh, I have to give download the image. Okay. So here we will use the model in order to generate the caption for this image. So this is the pagodas in Bangkok, Thailand. So we, as the this time we gonna use the Gemini model in order to describe the image in text NLP. So yeah, we will also provide the data code search tool as an external knowledge to the code agent. So this is the answer from the LLM Plat Data Go Search tool. Okay, let's go to the example 3. There is the agent that solve your assignment and also submit to the professor via email. So this your agent not only solve the problem, but also send the email. But in order to send the email, they should have access to your email, and then they should have access to your Google Apps Script. So you can create the tools for your email and password. This is your Google Apps Script password. Here, password is the Google Apps Script password. You have to create the Apps Script password for your agent and then give access as a secret key to your program. Okay, so here we have 2 functions. Those will be the tools for your agent. The first one is the reading the PDF file, that you reading your notebooks, reading your textbook, reading your assignments and something like that. This is reading the PDF file. Another tool is sending the email. So this function is to send the email. So you have to access, you have to give the information about sender email, receiver email, and then this is the email subject and something like that. And you send the SMTP server protocol. And the model you are going to use is the Gemini. And then as a tool, you give the 2 functions you just write above, which is read PDF file and send email. You give these 2 functions as a tools, as input to the LLM model. And here is your prompt. So the task is they have to load the source file and what is the chemical formula for magnesia oxide and something like that. And then what list the different daily life examples given in the PDF file. And then you send, you ask the LLM to send the email to this one, okay, using the send email tools. Okay, so for the PDF file, the access is Science Class A, which is in here. So it will get access to this PDF file and answer your homework questions and then send the email to this address. So let's run this. Yeah, you can see the output. Okay, you save the file. So here we got the assignment DOCAs. And then, okay, the assignment is already sent. Let's see whether it's already sent to the email. Okay, here you can see that it's already sent to the email with the signed assignments. So this is the example how you can build an agent using the Hugging Face library. Okay. Okay. Another one is you can use the your agent in order to analyze the Excel file, CSV file, your data for you. You don't need to, work on the boring Python code in order to do the visualization anymore. You can rely on the LLM agents. You can give the additional tools. For example, here you give the input like NumPy, Pandas, Matplotlib. Those are we widely used in order to create the charts, graph from the CSV file, right? Seaborn, something like that. So now we are going to use those tools as the additional import, and then Qwen 2.5 model in order to run the data analysis tasks. So we ask the LLM model in order to extract the football information. We will give the matches.csv. Here is the football information with the CSV file, and then we ask like how many matches and how many which team won or something like that. We don't need to rely on the step-by-step coding here. We just give the file and then identify the library that LLM agent should use in order to solve this problem. And after that, so here you can see that the LLM agents are generating the code for you using the library you identify here. And then finally, you should see the graph generated by those code. Here. So they also automatically generated the chart graph you created from the tools you identify here. Okay, so this is the prototype using the Hugging Face small agents. So you need some golden scales in order to pick the AI agents for Hugging Face. But for with the Google Fathers AI, you need the minimal golden scale. So I will also show you the solution. Okay, so this is the Google Cloud. So here, if you want to build the AI agent like that can answers your business information or like your any homework or something like that, the first thing you have to do is you can create the cloud storage where you can upload your data here from the my bucket. I uploaded my notes that is like science class 8 the same, and then I can use this in order to make the chat. So for that you have to use the Dialogflow API that should be enabled in order to do the dialogue chatbot using the Fathers AI. You have to enable that. For me, I already enable it. And you have to go after you enable the Dialogflow API, you have to go to the AI applications. And in the data store, you have to attach your PDF file here. I also show the step-by-step screenshot in the PowerPoint file here. And after that, you can create the apps. Here, if you want to create the apps, you just click the Create App. And then you have to use the chat. And then you can start you can start using your chatbot. That's all. For me, like I already created the scientist agent. Oh, so I have to switch the account. And then here you can start talking to your agent. Oh, let me show this. Oh, I have to reshare the screen. Sorry. Yeah, so after you launching your scientist agent, you should see a interface like this where you can start talking to your agents. So that's how you can create your chatbot, your AI agent with the Fathers AI with the minimal code. But do know that this is a little bit expensive than using with the Hugging Face. So yeah, you can choose based on the skills or your technical team and something like that. So here with the Fathers AI agent builder, you can use for both structured data like JSON CSV. You can also upload the CSV file like your sales data and something like that. And then you can ask like we did before in the Hugging Face. What is the profit for this year and something like that. And you can also use unstructured data like your business information or something like that and build the chatbot so that like when the customer can ask you about your business, the AI agent will extract it from your PDF files and give the output to the user. So this is the step-by-step screenshot that I just created using the Vatas AI. It's quite easy and comfortable, and anyone can do it. So if you are interested in building AI agents, you can check the official documentation of the small agents and Vatas AI agent builder. Yeah, that's all for my presentation, and I'm happy to answer any questions if you have.
Great. Yeah, thank you so much, Ken. So it was really awesome. Okay, so folks, if you have any questions, if you're live, if you're watching this live, you can ask your questions. But if you're watching this later on, you can add your questions in the comment section as well. We'll just pass it to Ken as well. Okay, great. That was great. So talking about today's session, right? So you started with the what-to vector model and others, right? So
Yeah.
in our past, the last expert talk we had, we basically talked about how we give a prompt and how the vector is generated. So today you also again mentioned like, okay, this is a vector. So these models we have gone through, and now we are currently working with the agent. So it's really great, like for the folks to understand, okay, how we are going through in the AI landscape, right? How it started, and great. Okay, another thing I believe. Talking about Hugging Face or Google Cloud and others, right? I believe it is Hugging Face, as you mentioned, folks do require some coding skills, and comparatively in Google Cloud, they don't, right? But
Yeah.
there is obviously some constraint like the cost. Cost is added
Right.
here,
Right.
right? So I believe that's one of the reasons it's tough for the students to get in, right? So obviously, but if they can use them, so obviously that should be great. Okay, I believe there is one thing that you can do with you can do, that is, can you kindly share the notebook or the repository? I believe I did actually meet Theory
Oh, sure, sure.
in
I have shared.
2023. Yeah, you can just share it with me so that so
Yeah,
that I
yeah.
can add it in the comment
Sure. I'm
section.
happy to share it. I will send to your email.
Okay, great, great, great. So yeah,
Okay.
I believe folks are going to ask like, hey, can I just run the notebook, or can I just get the repository? So yeah, that is it.
Yeah. I will
Okay,
just send to your.
okay, that would be great. I will just add it to the comment section later on as well. Or you can add that in the private chat as well. You can just do that in
Okay.
the right portion. You can see that in a private chat.
Okay.
Okay,
I also send to your
you've sent that,
email.
right?
I will
Okay,
also send to here.
okay. Yeah, I can always see that. Okay, I'll just share these to our folks, the students basically. Okay, so I believe we are not having any questions. We're not getting any questions here. So yeah, thank you so much, Ken, for your time, and
Thank you.
I hope we will meet again in any other stream in future, right?
I'm
So yeah,
happy to do that.
okay, thank you so much,
Thank you
and
for
see
your
you. Yeah,
invitation. See you. Bye bye.
bye. Okay, so that was our stream about AI agents. So I also mentioned that in our last expert talk, we did talk about the vectors from prompt. We looked into something to check what the vector looks like, what's the co-simulation between vectors. And in my mathematics for machine learning series, I did mention how to get the similarity and so on. Today, you might be, if you're the undergraduate student, you might learn about a star search algorithm and so on. So we started with that a star search, and we also mentioned about how the Google team actually invented that or proposed the what-to vector model and so on. These are the landscape we did pass through, and then we went to natural language process, and then large language LLM, large language models, and so on, right? So currently, it's AI agents you can see in LinkedIn. You can look into like folks are building AI agents, but it's basically automating the process, right? In LLM or AI, sorry, in specifically the Chat GPT or Gemini, whatever you call it. So you were just providing some sort of input there, right? But you have to continuously put some input. But the concept of AI agent is different. That is, you just give him the context, the question, and some sort of document or link and something. Just instruct him properly. He'll do all of the task, and that should be good for you. So that's what is happening in AI market right now. Even like 2 weeks prior to this session, we had Raima Apu. So she was also mentioning that how the company is trying to include AI agents to their solution. So all of our sessions, about specifically the expert talk sessions, are correlated. So that's important to understand. If you have any questions, if you are unable to understand the concepts, um, feel free to ask the questions in the comment section, and also ask the question in our Discord channel. So we have our ML Summer School Discord channel, so we will have a Q&A session there. So I will basically try to make you understand what it is. So yeah, thank you so much for watching this live stream, and I see you in the next video.